Hello everyone, today we'll talk about the solution to the problem, making a large island. This is a very straightforward grid problem, especially for one that's classified as hard, because we are being told that we have to return the size of the largest island on a grid if we are allowed to choose at most one water cell and turn it to a land cell. And it's very simple because we know how to find the sizes of all the islands, and turning a water tile into a land tile, what it's going to do, it's going to create, of course, here a small island of size 1, and it'll get connected to all the islands above it, so above, below, to the left, and to the right. And we can, first of all, calculate the sizes of all the islands. Second of all, go through all the water tiles and see what the sizes are of the islands to the 4 cardinal directions, and choose the best option. Of course, we have to make sure that we don't count the same island twice, because it's possible that a single water tile neighbors the same island multiple times. In particular, if there is an island with an empty water tile within it, then it neighbors the same island 4 times, so you have to count it only once. But while finding islands, we can just simply mark all the tiles in that island with the number of that island, and then we simply remember the sizes for all the islands based on their number. And then when we are trying to connect a water tile with its neighboring islands, we only look at the numbers, we take the set of unique numbers and sum up their sizes. Code is pretty verbose, but it's very simple, mostly boilerplate, and very classic if you're familiar with solving problems like this. We have our height and width, we have our 4 cardinal directions, and there are 2 portions. The first portion will be calculating the sizes of all the islands and their numbers. Second is trying to connect with every water tile. So for sizes, it's trivial, we'll be numbering islands starting from 2 upwards, because 1 is a land tile that's not visited, 0 is a water tile, 2 upwards is a already visited land tile. Let's go through all the possible starting points. If this is not equal to 1, it's either water or visited, so we don't do anything. Otherwise, we want to visit the whole island. We do it by simply running a DFS. So we'll be counting the size of it. And actually, this is unnecessary since here I'm just taking the length of this stack. So because you could either maintain a size and increment it within this for loop, but you don't have to. You can simply not remove anything from the stack, and this is the choice that I made, so this size is unnecessary. And of course, we'll be marking with the number. Starting from 2, after every full island, we'll increment the number by 1. So we just go through everything that is yet to be processed in this island, go through all the 4 directions, new row, new column, we check if it's in bounds, otherwise we continue. If it's not in bounds, if it's not 1, so against water or already visited, we don't do anything, otherwise we mark it with our number, add it to the stack. And as I mentioned, sizes here are necessary because we'll be using just the length of the stack as the size for the island of this number. And again, this is Python, so you can easily add to the list while you're iterating over it. And finally, we want to take the maximum of all the sizes of all the islands as our starting result. And also notice that the starting result will always be at least 1. If there is a water tile, we can turn it into a land tile, and then the answer is at least 1. And if there are no water tiles, then there is at least 1 land tile, so the answer is at least 1. So our best is 1, or the best size of any island. And now we want to connect, for every water tile, try to connect its neighbors and see if that's the best island. So again, every row, every column. Now we only are interested in grid of RC being equal to 0, so if it's not, we continue. And let's get the set of islands it touches. Again, for every direction, new row, new column, check if it's in bounds. Check if it's an island, so that means that it cannot be a 0, and it won't be a 1 because there are no more 1s remaining, but it has to be 2 or more. Otherwise we continue, and of course we added just the set of all the islands that are touched by this water tile. And now the option is to take either the old best, so we take the maximum, or 1 for our water tile, plus sum over the sizes of v for v in touches. So for every island that's touched by this water tile, we take its size, we sum them over, add 1, this is a possible result, and at the end we just return best. So we either take a water tile connected this might be a largest island or it's just a starting island, but it will only be a starting island if there are no water tiles at all. So this is not really an interesting edge case.